Okay, we're going to get started. First of all, if I mark anybody's assignment twice this time around, I'm just going to fail you for that assignment. So if you turn in your assignment twice and you happen to change the name, right, you better make clear that it's because two people in this room basically handed in two sets of assignments, one time with their student number and one time just labeled assignment 1 or something, and then I marked them twice. Okay? That's half an hour of my life I will never get back. You will pay. Okay, number 2. You guys can ask yourself, how did you do this week? You should have handed in your assignment labeled with only your student number. You should have had your name at the very end. Okay? If you sent it to me in a Word format, I am not very happy. Okay? It needs to be in PDF format. Okay? I got 2 Word formats sent to me. Okay? So I need it in PDF format. Now if you did send it to me in Word this time, okay, I will convert it over to PDF. Okay? But I will not do it again. There's too many of you, and there's too many good reasons not to mark your assignments. Number 1, you only need 5 out of 5, or 10 out of 10 to get maximum number of marks. So if I blow off one of your assignments because you're ditching me and not listening to me and doing something wrong, I figure it's a good learning opportunity, but I really haven't screwed you in a major way because you can just do another assignment. Okay? And trust me, I am looking for any good reason not to mark your stuff. Okay? So I don't want it to be labeled ASS 2 or 3 or 5 or 6 or anything like that. I just want your student number in the label, and that's it. I will put it into that folder. That way we never mix it up with anybody. Last week was a nightmare. Not only did marking just take me forever, but after I got it all marked, I had to sort through and figure out everybody's student number, and it was terrible. And then, for whatever reason, my Excel spreadsheet didn't work, and so I lost it all and I had to do it over again. I was like, oh! You have a question? No.
Me? I do have a question.
Oh, ask away.
So if we didn't get our assignment back from you, does that mean you
thank you. So yeah, it's because I really liked it. I just wanted to hang on to it. No. If you have a Hotmail account. No. Okay, so for those of you who did not get an assignment back, chances are good you have a Hotmail account and your Hotmail server does not accept VIU information. Okay? If you did not get an assignment from me back, then what you need to do is email me with your student number and your name, and I will go and find it. As Brian found out today, that's not always an easy task because a lot of people didn't label their first assignments with their student number. So I literally have to go through and open up a whole bunch of them in order to find it. So if you can remember the name of it too, that will make it easier for me. Okay? So luckily Brian figured out the name of what it was and I was able to find it, but that's after I opened up 3 or 4 of them. And is that it? No, is that it? No. And of course I have to open it up and then I have to scroll all the way to the bottom. And you guys might think that's buck up, Elliot, that's not that much work. But you know what? It adds up when there's 50 people. So, all right? So just if you guys didn't get your assignments back, everybody else got their assignments back. If you didn't, then A, you have a Hotmail account, and you might say, what do I do if I have a Hotmail account? You have to go and add VIU as somebody that can send you, because what's happening is your Hotmail server is basically thinking the junk mail. So if you didn't get it back because you have a Hotmail account and you want it back, which I would suggest you do, then I would email me and say, hey, Elliot, I didn't get it back. Could you send it to this address instead? And I will send it to another address. Almost everybody has multiple accounts these days. And if not, then go in and change your Hotmail account parameters, put down viu.ca as an acceptable, and then what happens is then email me and say, can you resend it? But I probably got 11 people that came back to me, and they were all Hotmail accounts. So They just end up back in my account. So does that work for everybody? Does anybody else have any questions on that? Yep.
How do I know that it's sent to you after when I send it to the Dropbox?
He has little faith. You have to just trust yourself. Okay? So, what's that? You should be able to see it in the Dropbox, yes.
That's like this thing wasn't sent.
Okay.
See what you sent.
Okay.
Yeah, you should be able to always see what you put in the Dropbox. Once you put it in there, you can't change it. That's why sometimes people will put multiple copies.
Okay.
If you put multiple copies, you want to just make sure, you put down something along the lines of, number 2, mark this or something, because you don't want to be marking 2 copies of what you've done. Because then
So I had no problem adding it to my Mac, like you were saying, the Dropbox, show problems.
Matthew.
No problem on the Mac, so maybe
Yeah. Yeah, so, and if you ever have doubts, don't doubt yourself, but if you do have doubts, then just email me and say, hey, I'll get it there and I'll go.
Wow. I could see it from down here.
Okay, anybody else have any questions? Yes, Brian.
You said that if you submit it and then submit again, if you just have exactly the same file name, shouldn't it just copy over it?
I don't think it overwrites.
It doesn't.
I don't think it overwrites, but I'm not sure. So, I would put some asterisks or something,
Something
just to sort of highlight it,
Okay.
and
learn how to do
put
that,
your
yeah.
student number in there and then mark this one,
Okay.
just something so I don't, because I really don't want to mark the same people twice.
Cool.
So, anybody else have any questions?
I still can't get into Dropbox.
Okay, so right before you came in, we were discussing that, and what we decided was that if you, go to the start menu and go into the run box at the bottom and actually enter the address with the HTTPS : / whatever it is, then you can get there. Alternatively, if you go under My Computer and then go Map Network Drive and put the address without the HTTPS, it works.
Okay.
So ideally, I would get to the stage where nobody's using anything other than Dropbox, but
I don't think you can put the HTTPS in either way that you
Oh,
can,
okay.
but I have to have the slashes before.
so the slashes before, no H, and if not, then go plague the IT people.
Yeah.
They, they're already pissed off at me, so what do I care? So try it,
Okay.
okay? Anybody else? Richard?
For Dropbox or really any other program, if you're trying to figure out how to use it, so you don't need to harass IT people or professors in the future, you can easily probably find a easy tutorial video on YouTube that can answer all these questions.
For specifically us? Here?
But
Try it. Thank you very much. Anybody else? Alright, so I'm going to tell you guys something very simple today. Okay, that's the very first lesson here. You remember what I said in the first class, that all your any kind of statistical notation needs to be italicized. Okay? It does. Okay? I haven't started docking marks, but I'm going to start docking marks. It's really pisser when you're trying to get 5, 10 out of 10s, and you keep getting 9s because you don't do what you need to do.
If I copy and paste the answer from what you wrote, it's not italicized, and I can take marks off them, right?
You cannot follow me. That would be crazy. And I bet you I could find at least 100 people to say the exact same thing. Don't do what Elliot does. This is do as I say, not as I do. All right? Kevin?
So we could italicize our entire document and not lose marks.
No, I would dock your marks for italicizing your entire document. In addition to that, when you start writing P, right, it should be a little p, less than 0.05, you guys need to get the spacing right. This is not me, this is APA. And this is not me being anal retentive or anything like that. This is the way they want. Okay? And what they want is they want a little p, that should be italicized, then a space. That flips people out. They don't like putting extra spaces in, but you guys aren't printing, so you don't have to worry about wasting paper. Okay? Then the less than sign, then a space again. Okay? Now, you would be surprised at how many people get this wrong. Last year, I was beating my students over it after the second semester. This year, I'm actually drawing it on the board. Instead of just telling people, I'm actually drawing it on the board so that there is no mistake. Then there's a period, and then there's... Okay? When we start getting into sort of larger equations, so let's say you do T, okay? Degrees of freedom goes there, close bracket. There's a space here. Then it's equals. Then there's a space. Then it's a number. Then there's a comma. Then there's a P. Then there's a space. Okay? Equals. And then there's a space. Okay? Now, if you don't believe me, go look at the APA manual. Yeah.
Was there a space after the comma as well?
Yeah, there's always
Okay.
spaces after the
Yeah.
comma.
Just making sure.
I've got it screwed every.
There's a space after the comma!
Well, now you can't say you tell us.
That's true, thank you. All right, so it's not that hard, pretty simple instructions, and hopefully, by the time you guys hand in this assignment, you guys will be doing everything right, and I won't have to harp on you for the rest of the semester, or dock you mark because you're dishing me and not listening to me, which I can't help sometimes, but take it personally. I'm a sensitive type of guy. Right? So today, we got a bunch of slides, but we're going to start by just talking a little bit about your last assignment. Yeah, so if there are people in this room who are unsure about their answers on the last assignment, okay, or what I wrote next to their assignments, you need to come and see me. And I swear to God that these two classes that we've just passed and the one more that we get in a couple weeks from now are the foundations of this. And sometimes it's painful to come see me. I've even heard that I'm intimidating. Which I can't really believe, but with that being said, I want you guys to come and see me. Okay? Usually it's fun, for me. I beat up Kevin today, I beat up Peter today, and we went over the answers. And the reason that these two chapters are so important is because A, from this point forward, I'm going to assume you know this. Okay? It's like IVs and DVs and internalizing this stuff. I'm going to assume you know it. Okay? In addition to that, I am going to assume you know this material too. Okay? And if you don't, then it'll permutate all your assignments from this point forward. And what happens is that, and I don't want to happen to anybody in here, what happens is that you get a little dodgy, you manage to make it through this semester, and every semester since I've been teaching this class now for 4 years, every second semester I end up losing a few students because everything builds, and by the time they come back here in January, by the time you start doing the second semester in January, it all is, it's not there anymore. And so you got a shaky foundation which is weakened because you've had too much turkey and drink over the holidays. You come back, we do a half an hour review, and boom, we start going into hypothesis testing, and all of a sudden you guys are like, oh my God, I don't really understand this stuff. I didn't really understand it before, now I really don't understand, and now I'm actually requiring you to sort of engage that material. And then so what happens is people start getting stressed. And I usually lose 2, 3, 4, or 5 people every year just due to anxiety second semester. And I do not want to lose people. So spend some time going over this. If you have to bug me, okay? I have nothing to do in the mornings except for deal with you guys. Especially Tuesday, Thursdays. Okay? So come and see me. And people have learned that the earlier you come and see me, the more likely it is that you're going to catch me unabated, without a lineup. So, if you come at 8 o'clock in the morning on Wednesday or Thursday, I'm usually sitting in my office. Today's Tuesday, so I usually don't get here till 9 on Tuesday, but, do not let this stuff accumulate. So if I've not given you the marks you think you deserve, or you don't understand why you got the marks, then come see me.
I know your office hours isn't the same you're on Monday, but sometimes you're here, is that something we can count on?
No, in fact, I get really resentful of having to be here Monday, because that's when I usually do my lesson prep. So, you can count on me being here Tuesday, Wednesday, Thursday. Monday, if on the like last week I had a faculty meeting, this week I had another faculty meeting, so I had to be here. Next week I plan on drinking somewhere in a bar in Vancouver Monday, crying, working out my next stats lecture. So, I don't know yet. And I wouldn't tell you because you'd probably show up. Hey, Elliot, I just got one question. Are you open for business? That's what Kevin says when he's outside my door. He says, you open for business? Yeah. My door's open. I have an open door policy for that reason. So please come and see me if you're starting to struggle, because like I said, we're going to move faster now. So I'm just going to go over a couple of things where most people got answers wrong, okay? In order to get full marks on number 2, you needed to talk about percentiles as well as Z-scores, okay? So when I ask you to describe somebody's score and I give you a Z-score, if I'm asking you to do that, then what I'm looking for is I'm actually looking for how'd you do in relation to everybody else, and that would be a percentile measurement, so I'm in the 97th percentile or the 98th or 99th percentile, so that's pretty damn good. But then I said, are you part of the group? And so that's my way of indicating that I want you to tell me whether or not there's a significant difference between you. Are you abnormal compared to everybody else? And so that's when you actually would use the Z-scores, and those critical values, the 1.96 is a critical value, okay? Now, most of you guys aren't referring to 1.96 as critical values, but in some senses, that's exactly why we pick 1.96, is because it basically gives us a decision line. If we're above 1.96, then we're in the 05, we're less than 5% error. If we're within 1.96, we're in the 95th percentile of the middle group, and so therefore we can't say there's a difference between us and the rest of the group. So the 1.96, if you're going up to 0.0 and alpha 0.0, then it's going to be 2.33, and these are called critical values. They're decision rules. Okay? We're going to say you're different if you fall outside of the 1.96. If it's a one-tail, then of course we put the 2.5% error and the 2.5% error all on one side, and that number becomes 1.65. Okay? If you fall outside of that, then we're going to say you're different. Okay? And he talks, oh, and here's another thing, okay? I heard by rumor that people aren't reading your textbook. This is not first-year psychology, people. Okay? You need to be reading your textbook before you come to class. Okay? Andy and I do not differ that much. Okay? But you need to actually be doing that. I know a lot of you guys have made it here to school through all your, I mean, how many people barely ever read your textbook? Don't tell me, I'll be depressed and suicidal. Lots of you guys do not read your textbooks. This is not the textbook to be and the class to be doing that with. Okay? If you took my first year class, let's say, well, you know, if you understand all of this, you don't need to read the textbook. This is not that class. Okay? Me and the textbook see eye to eye. And so you need to use the textbook because you need this material twice or three times before you get it. So that was question number 1. The next one that people did wrong, and it really is absolutely necessary for you to get, is number 4. Okay? And I apologize to Peter, because Peter and I went over this morning repeatedly. The fact is that I'm going to ask you something tricky on the exam, on the midterm, about why is it that we reject the null, or fail to reject the null. And what does that mean anyways? What are we actually testing? And this is confusing. It's intentionally confusing. Well, it's not intentionally confusing. It's confusing because we've never really thought this way. Why is it that we always find in favor of, why not find in favor of the alternative hypothesis?
You're looking for someone to answer the question?
Sure, go ahead. You feel up to it?
Because there's always a chance of error, so you can't say for sure.
Okay, so let's not put it into terms of error. Can you put it another way?
Because we either
It's hard now, isn't it?
Yeah, it is.
So
We either
let me try.
reject the null hypothesis or fail to reject the null hypothesis.
Why not? Why not? I mean, we have samples. We got the alternative hypothesis, which is about the sample. Well, why don't we do that? Why are we talking about? Because didn't Elliot say last week that the null hypothesis had to do with populations? We don't deal with populations. We deal with samples.
Okay.
So why are we talking in terms of populations when we're actually dealing with samples?
Okay, because there's no point. The sample is just a representation of the larger population. So if you're only dealing with samples and you're just wasting your time, what kind of, you got no power, you got no nothing. It's basically a pointless thing.
Now you guys think about it. What's that?
That was confusing.
Yeah, it is confusing, isn't it? And this is where I get into that analogy, like statistics is a little bit like a ghost, right? Sometimes you see it, sometimes you don't. I'm just going to tell you guys, because I can tell you what the answer is, okay? But I just think you should figure it out yourself, okay? Peter can tell you. Ask Peter. He knows that.
Not in this pressure.
Just get him rolling in the hallway and ask him. No. So the fact is that we develop evidence. So the example I used with Peter this morning was, let's say we were interested in a particular drug in depression. And we go out and we measure a group of people, and that's some measure of spread. And so this is our difference. This is the level of happiness, and this is the control group, and this is the experimental group. And I say, so our hypothesis would state H0 colon mu experimental equals mu of the control. There is no difference between those two groups. Okay? Our alternative hypothesis, or some people like to call it research hypothesis, is x bar 1, or E, does not equal x bar C. And it's a two-tailed, so we put equals, it doesn't equal sign there, instead of a directional hypothesis. But if we had a directional hypothesis, then we would do something like this, depending on which group we thought the drug was going to, which direction the drug was going to work. But we're going to do a non-directional hypothesis, so it's going to look like that. So we go out and do the test, and we get this. We run a statistic that generates a probability of what? It generates a probability of this event occurring by chance. That's what it tells us. It tells us B is equal to 0.04. So that means this event could occur by chance. If we just took two groups at random and then measured their levels of happiness, this could occur 4 times out of 100 by fluke, by happenstance, by who we selected for each group. So 96 times out of 100, it's happening because something systematic is going on. Well, what's the only thing that's systematic? If I use good experimental procedures, so I randomly sampled, I randomly assigned, blah, 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 then where is the difference coming from? The only difference is my alternative. Please accept my alternative hypothesis, because that's the only difference that we could account for this difference. But I don't have any evidence of that. All I have for evidence is that this is not true. This says there is no difference. I've decided, because I've reached my critical value, and I've assumed now that it's statistically significant, because it only could happen 4 times out of 100, I'm going to say, this is not true because look. So I have evidence against this, don't I? I have nothing in favor of this. Because I didn't realize when I selected people that were all born in one astrological sign, and Venus was in rising that week, and they happen to be happier because Venus is in rising. But I didn't know that. Who knew? So there is always another explanation, isn't there? So I can't say anything about this other than to ask you to accept this. Implicitly, or explicitly, I guess, explicitly, I'm going to say this is not true. So I'm going to reject my null hypothesis. Now, if I did the experiment and the probability came out to be 0.37, and that the error bars look more like this, well, I can't say now with any definitive authority, I can't say this could happen by chance 37 times out of 100. So I can't ask you to believe this. If, in fact, this could happen 37 times out of 100. So I fail to reject the null hypothesis. Again, it doesn't mean this is wrong. It just means that I don't have the evidence for it. Now, ideally, this should be crystal clear in your head. And I hope it is. Because I am a master at messing you guys up on the test. And I'm going to try. Because I really want you guys to know this, as opposed to just for think I know it. Or I can regurgitate it to you, Elliot, if you ask me the exact way I want the answer. Okay? But I don't want you just to be sort of regurgitate, and I see people, they regurgitate stuff to me all the time, okay? I use Peter as an example. He cracked a number of times to just try to regurgitate what I said to him. And it just doesn't work, does it? Not really. Okay, so you have to be able to internalize this. And the only way I can encourage you guys to do this is by trying to explain it to somebody else. Okay? Jamie and Jordan probably will actually be able to attest to the fact that once you start teaching people, you can actually exponentially increase your learning. That's one of the reasons why I encourage people to work in groups in this class. People are always saying, oh, you grade the curve and it creates unfair, people are competitive. Well, welcome to the real world. But with that being said, there's no curve in this class anymore, so you guys should all work together in a big cohesive group. Try to explain it to each other. Okay? Yeah?
We're having another meeting on Friday for anyone who wants extra.
Yeah, we have extra help scheduled for Friday. So, as well. Torture them.
By the way, you have chalk all over your jacket.
Yeah, I know. It's sorry. Alright, so what else did people do wrong? And you ever prove anything with statistics, curves, normal curves? The normal curve is a probability curve, people. That's all you had to say. We know what the probabilities are of certain events occurring. Okay? So a normal curve just happens to be a normal shaped one where we know that the probabilities are. But there are other probability curves. There's chi-squared, there's f's, there's t's. They're all curves, they're all probability curves. They're just not normally distributed. They're distributed in other fashions. So the one that people also seem to get wrong is systematic, unsystematic variance. That's pretty easy, right? Systematic variance is what we're trying to create. You're not ever trying to get rid of systematic variance. You're trying to create it. Okay? And unsystematic variance is basically error. The last question, what is meant by these things? Lots of you guys sort of bailed on me in the sense you just sort of... Some of you guys even went so far as to say, well, they're all kind of the same. Believe it or not, they actually each have their own independent meanings. And they're actually relatively significant. Okay? So, for example, number 2, statistics is much like a drunk uses a lamppost for support, not illumination. Statistics never tells you why something is the way it is. It only tells you whether it's statistically significant. It only gives you the odds, the probabilities. The explanation comes from you. And ultimately, you make that decision whether yours stuff is significant or not. You have to be that judge. And ultimately, you are doing the same thing when you read somebody else's paper. You are making a judgment about how much do you trust that other person's result based on the information that they provide you. Who they are, where they published, did they put error bars on their graphs? What was the standard deviation or standard error or standard or confidence intervals? Did they show? What does that mean? Okay? I don't ever believe a paper until I sort of ask myself, at least sort of 50 different questions. So in some senses, I'm not looking for statistics to provide me with explanations. Statistics just provides me with illumination, and that's what that means. Okay? Facts are stubborn. Second to the last one. Facts are stubborn. You can't change facts. But statistics are about odds, and you can change the way you judge those odds. I said, no, I don't believe that, but then I needed to because of this other experiment. Okay, well, that's now okay, maybe I can change what I accept, what I call. At the end of the game, it's basically coming. That's why I hate it when, this new trend for researchers just to report the probabilities. Instead of saying whether something is significant or not, I say, step up, you've done the experiment, make a decision. Don't tell me that the probability of the observed events occurring by chance are 0.6. Is it significant or not? Make a decision. Shit or get off the pot. Okay? Seriously, you can't just go through life sort of going, I'll let you make the decision, Elliot. You're the reader. Okay? Did you do the experiment well? Do you feel confident in your results? Then make a decision. Okay? So, the first one, which is, can I ever prove anything with, I can prove anything with statistics except for the truth. Well, first of all, statistics don't let you ever prove anything. It's all probability based. I used the example earlier today about the guy in Ontario who was basically stealing people's lottery tickets. When they came in and said, here, can you check my lottery ticket? He checked it and said, oh, yeah, my God, you won $20. Here you go. Well done. And then he'd put it in his pocket. And then 3 months later, his cousin would go and cash it in for $100,000. And so what they did, a statistician at the University of Toronto basically calculated the odds because his cousin won, his second cousin won, his daughter won, his nephew won, his brother won, his uncle won.
What a racket for a minimum wage job.
Oh, well, and how much, I mean, obviously the family was getting considerably wealthier. They're in jail now, most of them. So basically what they did is they hired a statistician to figure out what are the odds of having, 6-year relatives win a major lottery, given that this is the odds of winning any one of those lotteries. And it worked out to be like 250 billion to 1. So he's in jail. And he happened to own a lottery booth, or a lottery kiosk. And so he's in jail. Now it could be that he's just really lucky, isn't it? It could be. He could be some poor schmo and his family was just all really lucky. Or it could be that he's ripping off the system. Which is it? I mean, the courts decided against him. They said, sorry, it's just not probable. And they put him in jail. But he could be telling the truth.
Yeah, it could have been an astrologer and he just did all the charts and got his people.
Maybe he figured out a system to crack the lottery corp, right? But again, they didn't buy that. So, anyways, those are sort of the answers to those questions. So today I'm introducing you to SPSS and Excel. And so this is going to be fast and furious, but in case you guys didn't notice, I am actually wearing a mic. So if I am doing things right, then I am currently recording everything you're about to see. If what I show you is confusing to you, feel free to bring a jump drive to my office, and I will give you the recording. And then you have to listen to my irritating voice on your headphones, which would be painful. So watch carefully, and hopefully this won't be necessary. Yes? No, I'm just joking. Yes? Did somebody else have a question?
That's what I was gonna ask.
Oh, okay. I like having a board, I get chalk all over the place. This is Excel. Oh,
Sorry, I was just wondering what time extra help is on Friday?
Like 9:31.
wow, 9:30 to 1. Holy smokes. You guys are really lucky. Okay? I would take advantage of that. Okay? Anyways. I'm going to try to do everything that I want you guys to do for your assignment. Okay? So, usually I start off, because normally I grade this class on a curve. Oh, by the way, but I'd say 90% of you guys answered the curve is fair. Okay? Obviously, given who I am, that's the right answer. For those of you guys who said no, as long as you mounted a good argument, then I would have concurred, but nobody did. So, now I could say I'm biased, and that's probably true, but here's the thing, okay? I want you guys to think about this. Every major institution in the country, and probably in North America, uses a normal distribution or a requirement of a normal distribution for their professors. Now, they've learned over time not to come out and say, we grade on a normal curve, because that freaks people out, and they get all this, it's going to be competitive, blah, blah, blah. But what they do is they basically have a requirement to grade basically on sort of a fairly commonly held, I'll put this back, I promise. They do a normal curve, and they basically say, look, we sort of expect that 20% of your class is going to get A's. We sort of expect 30% of your class to get B's, 30% to get C's, and then the remaining 20% to get D's and F's. Now, nobody's ever doing this in a group less than 30, because it doesn't work. But you don't usually get classes less than 30 anywhere else except for here. In some senses, VIU should be really a destination school for lots of people, because you actually do get classes that are 30 or 34 hours are maximum in social sciences. You go to other colleges and, their first year, second year in stats classes, stuff like that, they're at 60 or 80, 90, 100. You go to first year psych anywhere else and it's 600. Carleton has 1,800 people a class. Dalhousie has 1,800 person classes. One professor, 1,800 people. Your professor can't even see what you look like when he lectures. Might not be bad. No. So the curve is not, the curve. And the fact is, too, is that if you get the average grade, then you get the average mark. So to me, being graded against my expectations, which you guys will be graded against in here, is actually worse than being graded against the quality of your colleagues. Okay? And every year I graded on a curve in this class, people have always said, there are going to be people not helping and that sort of stuff. And every year is completely false. Every year, people work in groups in this class. Not everybody, but 90% of people work in groups. Sometimes they're little two people groups, sometimes they're 4 people groups, sometimes they're 5 people groups, but people tend to work in groups, okay? So competition, not really. Number 2, if you get the best mark in this class, regardless of what my expectations are, don't you think you should get an A+? And it's hard when you have somebody like me who makes up new tests every exam. I don't just keep using the same old shit. You guys all know you can take classes in which you can get a hold of old exams in which the professor uses 80 or 90% of the material in their new exams. You guys all know that. Again, it's your education. If you want to, throw that money away, all the power to you. But the fact is that I make up new exams every time. So for me, grading on a curve is really the only way. And it's the only way that I think it can be fair. If you're below average, well, you get a below average grade. You shouldn't get 90 just because you scored some mythical percentage, okay? Some arbitrary percentage that UBC dreamed up and BIU said, well, we got to be the same as them. I'm saying this on tape, shit. Nobody can have this tape until I edit it, yes.
What was the average grade on the assignment?
Oh, probably around 7. Okay. Lots of people got 10s. And a few people got below. If you got below 7, okay, then you need to figure out why. And then you need to sort of start amping up your effort. Okay? Amping up your time spent. I mean, and we're going to, I'm going to start going here. Because otherwise I'm not going to get it. So this is a class, okay? This is an example. I actually took these numbers directly from a class. And I made it a little bit smaller. This is Excel. Welcome to Excel, file open, all that sort of stuff. Most of you guys know how to do that. So what do? I need to figure out a way to grade these people. So it's quite easy to do. First of all, I need to figure out what the average is, don't I? So to calculate the average, and I usually label things first, so I just AVG. And so equals average, bracket. And then there's this click and drag function, Excel. So if I click in that bottom cell and then I get this little, see that I got a fat plus there? This is a, hang on here. Oh, and then I just click and drag it all the way up. Oh, shit. Oh, no, that worked. And then close bracket. Okay, so you see the formula, average bracket, B2 to B35, that's the whole row. And I hit return and I got the average. You guys know how to calculate standard deviation. How do you calculate standard deviation? Equals, in Excel, it's pretty easy, STDEV, okay? STDEV, close bracket, click and drag. And I just click and drag and I got the whole row. So there's the formula there. So STDEV and B2 to B35. What's standard error? Standard error is standard deviation divided by the square root of n, right? So there are 35 subjects in this class, 34 subjects in this class, so n would be 33. So equals standard deviation, which is then the cell right above it, divided by SQRT, close bracket, 33, or open bracket, close bracket, and now I have standard error of the mean.
What's the abbreviation?
SQRT. So now once I've got that, so this is their first exam, this is their second exam, so once I've got that I can highlight those 3, and I can drag that over, and Excel will extrapolate for me. So see the little cross there I got? That little cross is what Excel goes to sort of say, hey look, I'm going to extrapolate for you. I'm going to move everything over by 1. So if we look at the equations here, the equations stay the same, they just change from B in this row to C in that row. Well, that's pretty convenient. So, now let's say we wanted to weight these scores. Do this again. So we're going to do exam 1 is worth 40%, so let's put 40 there. And exam 2 is worth 60%. Okay, how do we weight that? Well, what we can do is we can go equals that times 0.4. And we can go equals that times 0.6. Can you guys all see that up there? Okay. So now those two scores have been weighted by 40 and 60%. Everybody follow me on that? Okay. If I lose you guys, shout at me because I'm looking at the screen, not looking at you guys. So if I want to extrapolate from that, I can actually highlight those two. Okay. instead of having the big fat cross, get the little cross right there, little black cross, click and drag, and Excel will extrapolate all of those numbers down using 0.4 and 0.6, but extrapolating and changing the B from B2 to B3 to B4 to B5, or C2, 3, 4, 5, so on and so on. So now I've just got a whole weighted score. So now if I want to total that, because of course this is the total, so then I can sort of say exam total. And again, labels are relatively important when it comes to research or entering anything into spreadsheets. I can say equals, and it's pretty easy, just that, plus that. I know this is like really rocket science, boom. So now I have a total, and again, I can click and drag. But, little did I know I didn't need the total because I grade on a curve, right? So now what do I need to do to grade on a curve? What do I need to grade on a curve? I need people's z-scores, don't I? Okay? So, and that's based on their total score, so let's do that. Oh, so I didn't need the total. So I can actually click here, take all those, get the little cross, extrapolate, boom. Now I have all of that. So what's the average score on the test? When it's with the weighted score, looks like it's about 45.9. 45.9 on my test. That's odd, eh? It's relatively low, isn't it? Yeah, it's a good thing you guys aren't on a curve. So now I need a z-score for this, because these guys, unlike you, are going to be graded on a curve. You guys, of course, are being graded on percentage, but, how do we calculate it? Well, what is a z-score? It's your score subtract the mean divided by the standard deviation. So if we go your score, which was 47.6, you're right, just a little bit above the average, subtract the mean, which is way down here, close bracket, divided by the standard deviation, which is 13, okay, we get a number. So this person's z-score, a little bit above the mean, is 0.12. Probably right about where you'd expect it. If you put it on a normal curve, it would just be a little bit above the mean. The grade that they would probably receive would be sort of in the area of a B minus. Had they got 0.33 or 0.34, they would probably be in the area of a B, and if they got 0.67, they would be in the area of a B plus. But this person got a B minus. So now if we clicked and dragged this, what would happen is that Excel is going to extrapolate each of these numbers, and we're going to get a bunch of errors. Okay? Now the reason is because Excel basically is extrapolating the mean and the standard error and adding one to each of those. And we don't want Excel to do that. We want Excel to use the same mean and average. So what we're going to do is we're actually going to tell the Excel that we want them to keep it the same. So all we're going to do is go $, and $, right here, and hit return. The number stays the same. But now when we extrapolate, what Excel is going to do is it's going to fix those two numbers, keep them the same, drag down to the bottom, and now we have everybody's z-scores. So we can see how now if we wanted to, we could actually highlight these people, which is what I do, and then sort, under data, sort, and we want to basically sort on their, no, I don't want to go to values, hang on here. No, I want that. What am I doing wrong here? Cancel. I don't have a total. So this is Z score. And try this again. So if you guys want to get through columns quickly, you can use the Control and Shift together. And then you can actually, it'll go down to the next for the first division. So if you go Control, Shift, and down arrow, that'll take you to the bottom of the spreadsheet. Okay? And then under sort, and we're going to sort based on z-scores, and we're going to go, I usually go largest to smallest because I'm an optimist. So there we go. So this person actually scored, has a z-score of 2.38. What letter grade do you think they should get? The next person closest to them is 1.5. Do you think this person deserves an A+?
Yeah.
Probably yes. You guys want to look at in graphical format? So let's look at it in graphical format. So, there's going to be a normal curve, right? We got over 30, so it should look like a normal curve. I haven't graphed this at all, but let's take a look at it. So let's do a frequency histogram. So, in order to do a frequency histogram, what we have to do is we have to sort of say, well, how are we going to break down the bins, right? Because frequency histograms show you collections of numbers. So from 0 to 0.33, it's going to put everybody in that category together.
So how do we want to break people into bins? Well, usually at the highest mark is 0.323, so let's start at 2.4, and then let's go 2.2, and 2.0. This would be really tedious if I had to do it the whole way, but luckily Excel has a very good extrapolation routine, so we can click on that. Drag all the way down. Oh, there's 0, and then down here, and then I don't know what the lowest one is, but let's put it down to 1.2. What's the lowest one?
That require only 3 values.
Yeah, it'll try even with 2, but it's better with. So the lowest is 2.88, so obviously I got to go down further. So highlight those and extrapolate down to 2.8. So now I've got sort of what I'm going to bin my data. So I'm going to bin my data into groups of basically a 0.2. Okay? So now what I'm going to do, and hopefully I can do this here, data, and under here, data analysis. Now a lot of times when you guys open up Excel, you won't see this little button, data analysis. So what you need to, what's that?
Maybe I'm just a little behind, but where did the 2.4, the 2.2, where did the...
I'm just guessing. I want to bin people, and I roughly want to have, maybe 3 or 4 people for bin, maybe 5 or 6 people in the center at the average mark, and so I'm just picking 0.2 as a denomination. So everybody within a 0.2 area of each other is going to be collected together.
Okay, perfect.
So if you don't have data analysis, then you can go under this sign and then say Excel options, and then under add-ins right here, you can actually go here, and then you can click Analysis Pack, which is right there. And Jamie and Jordan can help you in lab with that. But under Data Analysis, we're going to click on that. We're going to say Histogram, because that's what we want is a histogram. So we say OK, and then it says Input Range. So Excel is asking me what range. Well, the range I want to use is the raw scores, and so that's right here. So I click and hold my mouse down, and I drag. And then Excel says, well, what's the bin range, Elliot? Well, I can click here and drag and say I want the bin range right there. This is probably too big of a span, but for grading I find it very advantageous. And then I say, okay, good, excellent. It says output. You want it on the same sheet or a new sheet? So we'll say a new sheet. So we'll say, okay, it's a new sheet. So there's my output. And then what I can do is if I want to, I can just go straight to Insert and go Column. And there's my frequency histogram. All right, so now if I was grading people on this, there's lots of things I hate about this curve. So if you guys are ever doing Excel charts for me, frequency doesn't really convey any information, does it? Of course it's frequency. Frequency of what? I don't know, but it's frequency. Of course it is, so we can get rid of that. These lines, I don't really need these lines. I'm looking at 1, 2, 3, 4, etc., so I can get rid of those. Now, if I wanted to sort of help with my grading whole process, and grading on a curve is difficult, and I like to show students this, I can say Insert Shape, and I can take that and say, oh, what's the mean? The mean is 0. Because this is the normal distribution, right? So I'm going to draw a line and make it straight. And I'm going to say everybody above that line is going to get a B or an A, everybody below is going to get a C or D or F. I could actually do a couple of those lines, actually, if I wanted to, and say here's one standard deviation. That's the division between the A's and the B's, isn't it? I could draw a line like that. And I could copy that line and paste it again. No. Okay, maybe not. I can paste it, but I can't. I always have a hard time getting it because it sticks it over on the side. So then I can put one here. Now, for grading purposes, if I was telling you guys, hey, this is your class, okay, what do you think this person should get? A+. It's obvious. They are miles out in front of everybody else. Now, by nature of them getting an A+, if I gave this person an A plus 2, don't you think I would be diminishing this person's A+? That would be bad. I'd hate to have an A+ and have it diminished by having somebody who wasn't quite as good as me getting the same mark. Right? And if you want to shine, you're going to shine. So you want to be up there. So if there's a group of people up there, I can't give everybody an A+, so what happens is then I have to reevaluate. Now when I grade, I might have 10 of these charts that I do. You can get a different look at it by just changing the numbers. Instead of saying 0.2, having 0.2 size bins, I go to 0.3. Things will distribute a slightly different way. Okay, and I can keep doing that until I can find a curve in which I actually can see. And if you guys ever have the opportunity to grade like 600 people, which I have had to do, when you grade 600 people, there are clear division lines between the A's and the B's, between the A pluses and the A minuses and the A's, there are clear, like there's gaps. It's not arbitrarily set by some board of governor asshole. Oops. It is fixed. You guys are definitely not getting this tape now. It's fixed. It's determined in advance. This is actually based on you guys. We're looking for natural occurring divisions between your groups. Yes, Richard.
I sit on board of governors.
Yeah, well, it's not the board of governors anyways. It's the grading quality something. Do you think this person should get an F? Yeah, come on. Do you think that these people should get Fs? Below a 1? I mean, there's a nice gap there. D's, all right. Look at you guys. You guys are such island people. I love you all. It's nice, you're just nice. So I can use this to grade. I can look at this. I can plot it a bunch of different ways. I can put the mean and standard deviation up on this chart so you guys can all figure out what your own Z-scores are. How'd you do in the relations to real group? I can go back to my class list and I can start grading and say, okay, A+. I know this person's going to get an A. And then I can sort of take a look. Do you think this person should get an A? No, I think that's an A-. Look at the gap between those two. 1.5 versus 1.26? Wouldn't you be pissed off, Brian, if you were the 1.5? And Courtney right beside you got 1.26? She got the same mark as you? She'd just be laughing at you.
No, I'd be happy because I don't want to get the end of it.
Oh, okay. I didn't realize there was competition then, So I would say that person deserves an A-, A-. Oh, look at that big jump there. 1.96 all the way down to 0.84. Well, I don't think the guy who got 0.84 should get an A-. It's below a 1. I said 1s and above are A's, below 1s. Oh, so this person's going to get a B+. And so on and so on. Okay? When I get dodgy about grading, I go back and look at the chart. Go back and forth. I redo the chart a bunch of different times. I go back and forth. And I look for those natural divisions between groups. And it turns out, oh, look at this. So between the B pluses and the B's, there's a little bit of a gap there, isn't there? I know, it works out amazing. It's like magic. I swear to God, it's like magic. It really is. It just happens that there are these natural occurring gaps. Should I let those natural occurring gaps decide your grades versus some arbitrary thing that somebody in 3 years ago decided to set, which was actually previously set by UBC 10 years ago? And arbitrarily followed anyways, because when people don't get the percentages that they don't get, then we just shuffle things around anyways. Oh, we'll just slide the curve up. Right? So, that's Excel. Now, if I wanted to, I could actually sort of say, I would like to get I want to do a chart, I want to do a graph. Well, what do we normally graph? Well, this is parametric data, so we would normally graph means. So let's do the two means for the two tests. So there's the first two tests. If I want to graph that, 45 and 46, not big of that difference, but what I can do is I can actually, Excel and SPSS these days, just trying to make things easier and easier and easier. Pretty soon, you can get your dog to do this, okay? So knowing what to do is harder to do, but getting to somebody to do it is pretty easy. So you just highlight those two things, those are the two means, and so then we're going to go, let's do something for giggles. Let's say this, we're going to change these numbers a little bit to throw things off a little bit. Let's go with 117.
What you do when you grade people there?
Yeah, absolutely. Especially if I don't like them. So let's say we're going to graph those two. And so what we're going to do is we're going to highlight that too. And all we have to do for Excel is just say insert. And then we say column. And return, column, pick the one we want, and return. There it is. Now again, don't like this. Doesn't tell me anything. Don't like this. So I'm going to get you guys to do Excel graphs for me, okay? You're going to have to. Okay, you guys will bitch about it. So one of the things that I do is sort of to tell people how to make it the right. Yep, what?
Can you set a setting so that automatically those lines are gone?
With SPSS you can. And I'm sure with Excel you can too, but I just don't know how because I do it every time. So if you want to make this the appropriate size to make it easy to sort of transfer into a Word document, which is where you guys mostly work, I say make it half a page. Okay? So I literally hold up your thing to your screen and make sure it's half a page. And if you do that every time, then it's going to roughly translate to half a page when you transfer it into Word. Okay? So, what else do we don't like here? Well, everything's got to be labeled. So we got to label everything. So we're going to actually move that up. 1 and 2 means nothing to me or to your reader. So do not ever label anything 1 and 2. Okay? Because now you're going to require to go look what 1 and 2 is. So 1 is midterm, the first midterm, 2 is the final. So what I'm going to do is I'm going to actually right click on that, and I'm going to say Format Access. And then I'm going to go and I'm going to say Tick Labels, None. So now my labels are gone. Okay? So then I can actually put Insert, Text Box. Now there's other ways to do this, and feel free to do it, but I do it this way, and there's good reasons for everything I do. I just don't do it by happenstance, but I'm going to say midterm. Okay? And drag that over to the middle. Okay, and this is and that's the final, right? So I'll just do the same thing, insert, oops, not that one, damn it. This one here, and say final. Okay, so there's your 2 marks, the average 2 marks of those 2 classes. Now I need a label over here. Okay, so this is a weighted total, isn't it? So I'm going to say insert, text box, type here, weighted total. It should be enough that I know, oh shit, I can't read that, can I? It's okay, because what we're going to do is grab that little green button right there, click on it, hold it, and then we're going to rotate it 90 degrees. Okay, now, you guys can actually spell out the whole word, weighted total, but, so there's, now what else is wrong with this? Well, it's really actually quite small print. You guys are required to have a minimum size print of size 18 font. For everything. You can go bigger than that, but everything has to be a minimum of 18. If you give me a graph in which these numbers are at 12, I'm going to circle them and say font. So what you need to do is you need to select all and then change it to 18. Oh, and then these you have to actually click and hold, or shift and hold, I think. Hang on here, yeah. Shift and hold, and we're going to change.
For graphs, right? You don't want written stuff in 18 size small.
No, just for graphs. All right. Now, the part of the problem is now I got to make some adjustments to this, right? Now, what did I tell you guys about error bars? I said, don't ever give me a graph without error bars, right? I'm going to make this, slide this down a little bit more, slide this down. So try to get things sort of neatly proportioned and centered, okay? Why? Well, because if it's not centered, I'll probably dock some marks and say this looks like crap. Okay, if you do something like that, leave it like that, I'll be upset, and I'll be like, this person obviously just doesn't care, and then I'll be, and I'll be like, okay, now I'm going to punish you for it. And I hate that, so, and then I'm going to move this so it sort of, looks good right about the middle. Okay, so there you go. So error bar. So if I click on that, see how I clicked on it once, I got these little round circles around each one? That says I'm going to be, whatever I'm doing to both bars. So then I'm going to go up to layout, and then here it says error bars. Oh, look at that, error bars. And there's a bunch of error bars here, but don't do them. Don't do them, don't use them, don't trust them. Okay, if you guys are going for Greek food, do you go to the Chinese food restaurant and order moussaka? Anybody do that? That'd be crazy, wouldn't it? Okay? If you're going to do error bars, you need to know what your error bars are. Okay? Do not let Excel make your error bars, because I don't know how Excel makes error bars and they never look right. And I know if you do, because there's secrets to that. So go to more error bar options, and then it says custom error bars, and we know what our error bars are supposed to be, and we can specify value. And over here we got standard error of the mean already calculated. Look at that. And standard error of the mean is always plus and minus from the mean. So we can actually say, click on this little red button. When you see that little red button like that, Excel says, show me what you want me to do. So I click on that button and I highlight these two. Click, click, like that. Hit return. And then of course we got to minus it from the mean too. So we hit those two and highlight those two. And voila. And then we can say OK and close. Now we've got error bars. Okay? Now if I print this on a black and white printer, those bars are going to come out black. And that's fine by me. I have no problem with that. I don't need to see the bottom if I know this is standard error of the mean. So now, the last thing, which will drive me mental, is this outside border. I hate this outside border. See this outside border? It looks so restricting. So double click on the outside border, double click, or right click, sorry, and then go down to Format Chart Area, and then go up here to Border, Color, and then say No Line.
You must be a rebel, eh?
Why?
Well, the border is restrictive to
It is a restrictive thing. Look at that. Doesn't that look better? So now I can actually click on this, right? Just click on the outside and control copy. I'm a conformist, actually, to be honest with you. I mean, I'm doing things by the way they're supposed to be done. Control V. Okay, well, it didn't quite work out there. My this is not quite far enough away, so don't be scared to just do a little bit of editing afterwards. Come on, get up. Take a look at it, and then we click off of it. Click off it, there you go. Beautiful, that's about a half a page too, isn't it? If we look at that, about a half a page. Yep, looks great. Now this is the part you guys are gonna love, okay? Figure captions, okay? If you give a figure caption to me, you have to explain everything in the figure, okay? Now I'm gonna stress this, do what I say. Okay, you will do well. F-I-G, you are, come on, type for me.
It's up there, it's on the top of your graph.
Oh, is it? Oh, shh. Don't do it up there. Do it down here. F-I-G, you are figure 1, 3. Should that be italicized or not? What's that? It should be. Figure 1 should be italicized. So, this bar graph shows. If you are giving me a bar graph and you do not type those 3 words first, you are going to lose some marks. If you're doing a scatter plot, you should say, this scatter plot shows. If you're doing a frequency histogram, you should say, this frequency histogram shows. This bar graph shows. What does it show? The means, medians, modes. It's the mean. We could have actually put that mean weighted total. Mean weighted total for stats 300A grades or scores or something. Okay? What would it say that? This bar graph shows mean weighted scores for statistics 300 at VIU. Okay, actually you shouldn't use VIU, so because people don't know what VIU is, so you'd say Vancouver Island University. Great. Yes?
What if our paper or whatever it is that this figure caption is in already references Vancouver University as being VIU?
Well, anyway, okay. Then you say the x-axis represents, in this case, it's the midterm and final. But if it was gender, then you would say gender. If it was, whatever it is, okay, in this case, I would just say the tests would represent the exams. And the y-axis represents weighted total marks. Great. What about the error bars? What do the error bars represent? Are they standard error of the mean, standard deviation, confidence intervals, 2 standard deviations, 3 standard, I don't know. Well, they represent the error bars represent standard error of the mean. Now I can do standard error of the mean as a statistical.
So you can refer to the error bars as just errors?
So what do the error bars represent? So the error, bars, just a typing error. The error bars represent standard error of the mean.
Okay, I have to check it.
Okay, or you can actually go, the error bars represent the mean plus or minus the standard error. Saying one or the other is fine, yes.
Does that have to be predefined in what's going on, or just we know it is?
Remember what I said, when you guys read papers, you should actually start with looking at the graphs of people? So as a result of that rule, every time you produce a graph, you have to explain everything that's going on in there. Even if you explain it in the paper, other than acronyms, and even with acronyms, you should actually have acronyms defined in here. Because if I start, and so I take that back what I said to you, Kevin, I lied. So you should have everything defined in there, because there are people like myself who will start by reading your figures. Okay? Like if you had a poster up at a scientific conference, I would go and actually look at your figures before I even let you put a word into my head. And I'm going to say, what do your figures tell me? And I need to know what they are. So you need to describe everything in the figure. Okay? That's what a graph should look like. It should be on half a page. It should have a figure caption. It should describe both axes, what the bars are, and what the error bars are. And there shouldn't be any fancy stuff. No flapping birds or sliding windows or anything like that. It should just look like this. Black or white. Yes?
So we don't need titles or anything?
No. In fact, some journals will require you to name your graph by putting it in the first sentence before you say this bar graph shows. So you would say something like this. Class, grades, stats, 300A. Yeah, either one's fine by me. So no title on the graph. And the reason is because when you go to publish, they actually take the graphs and it's handled by a different department. It's handled by the art department, whereas in your text, it's handled by text setting. So there are different groups of people that deal with it. So that's what it should look like. Question? Okay? Easy enough to do some other things. If I wanted to do, for example, if I wanted to go back to the original data, where'd the original data go? Class list. There we go. If I wanted to do a scatter plot instead, if you want to do the same graph over and over again, you can actually copy the whole graph and then paste it underneath. There's lots of tricks. You should learn these tricks. And then you can actually right-click on it, say format plot area. No, not that one. Right-click on it, say select data. And then you can go and change the data. So instead of that, you could say remove and then add, and then you could highlight 2 other spots. And then say OK. And then it'll actually insert, and I have no idea why that number's there, but it will actually go and fix that. So I'm more elegant when I'm not in a rush. I'm in a rush now. So you could also do sort of things like if you wanted to do a scatter plot, say look at the correlation between exam 1 and exam 2. How'd you do if you did well in exam 1 and how'd you do in exam 2? And that sort of stuff. You can actually go and say insert, and then you can just pick scatter plot. And voila, now you got a scatter plot. Get rid of the lines, label everything, get rid of the series, and then you can say, when you do a scatter plot, you should always actually add a trend line. So here it says trend line. That's also called in correlation the line of best fit. So you can actually say, I want to add a linear trend line. Voila, there you go. Now if you get rid of that, it looks a lot better. Get rid of the lines, it starts to look better. Get rid of the lines, it starts to look better. Okay, label everything, and now you got another graph. So for this assignment, you're going to have to do a scatter plot. So that's Excel. I'm going to leave that alone for a second. Whip over to here. This is SPSS. Welcome to SPSS. All right? It's not my intentions to teach you everything you need to know for this assignment. It's to give you a ballpark of everything. You guys will have to figure a little bit of stuff out on your own, which is okay because I'm looking at you and you all look very smart to me. So that being said, welcome to Excel. Excel has 2 views. They have the data view, which is what I tend to look at things, and then if I was going to enter a bunch of data, I can actually enter it in here. Subject, time, grade, depression, and stats. Weird, it's depression and stats go together in the same. I don't know how that happened. So I've got labels here. Sometimes your labels, you don't specify. Say, for example, time. What does that mean? Time spent it took, in this case, it was time spent it took revising, and you can actually click on that. Actually, you just scroll over, and it says time spent revising. So now I actually have a better idea. Was it minutes or hours or seconds? You could actually enter that stuff into the label. Okay? Here, exam performance, and exam anxiety, that should be depression. And then I can have labels here, gender, okay, oh, that's stats. So that's in stats instead of gender, it's in stats or not. And so 1, instead of 1 being gender, sorry, I copied this, I could actually change that to everybody who scored, I got a 1 there was in stats, and change. And then everybody who got a 2 was not. So that you can label basically. Now it's very advantageous for you to put your labels in when you actually have a data set. Okay? So when you open this data set online, I specify which one to open up. It'll have the appropriate labels, but spend a few minutes just looking at this screen, okay? That's data view. Okay? And again, you can put labels. Next week we'll talk about how to deal with missing variables. Okay? And we'll talk about that in this, and then we'll talk about scales too. Remember scales? nominal, interval, ordinal, ratio, okay? Well, these things, this one here, subject number is basically nominal, because it's not like 1 scored better than 2, okay? It's just subject 1, subject 2, subject 3. And then these are scale variables, and then this last one is basically nominal too. You're either in stats or out of stats. So it's just it's a dichotomous variable, binary. It's one or the other. So that would be, we just leave that at nominal, right? So we'll go back to variable view. Now, when you get data sets and you do things like grading students on a curve and stuff like that, I always spend a little bit of time looking at my data. Next week we'll work on data cleaning. So under the analyze key, you will see descriptive statistics. And descriptive statistics is just another way of saying describe. So what we can do is actually click on that and then click over to frequencies. And what that's going to do is it basically look at these 3 variables, okay, because those are the 3 continuous variables. And we're going to actually look at the statistics, and what we're going to say is we're going to say statistics. What do we want to see? Well, do we need to see quartiles? Percentiles? Well, when do we need to look at quartiles and percentiles? When we deal with median statistics, ordinal statistics. Is this median or ordinal statistics? And it's not. It's parametric. So we don't really need to see this, but I'm going to leave it in there just so you guys can see. Measures of central tendency, mean, median, and mode. Sure, I want to see those. If I want to see the percentiles and I want to see this, I'm going to do quartiles, so do I need to see this? I don't need to see that, do I? Because I'm already getting that when I say quartile, so I'm going to get rid of that. I want to see the standard deviation, the variance, the range, mins, maxes, and standard error. Boom, it's all going to calculate it for me. Isn't that a wonderful thing? Oh, look at that, skewness and kurtosis. I just click those buttons, it's going to tell me what the skewness and kurtosis is. So we say continue. You don't have to worry. Now it says, do you want a chart? Oh, I'd like to see a frequency histogram. I showed you guys how to create one in Excel, but it looks like SPSS is going to do it for me. And I'm going to say, hey, put a normal curve on that for me, because I like normal curves. And then format and style, you don't really have to much. Now frequency table, that's just, you remember when we created that frequency table, it said how many people were in each group? Everybody awake? Good. So it says how many people are in each group? That's what a frequency table is. I don't really need to see how SPSS is doing that, so I'm going to just say okay. So SPSS goes away and calculates that for me, and look at that, it's beautiful. There's the mean, the standard deviation, the mode, variance, skewness, kurtosis, mins, maxes, percentiles, quartiles, oh, it's all right there. Just boom like that. Now if I wanted to, I could actually copy that and actually put it into Word, and I would put it on a new page. So insert, page break, and put it, oh look at that, isn't that nice? Okay, so it's a good way to show data to me, okay? But if I'm only asking for one thing, do not put the whole chart in there, just put the one thing in there, okay? So we go back to SPSS for a second. Now, we've got 2 different groups. We've got people in stats and people not in stats, and so we don't always want to measure everybody. I'm just going to throw that away. Do I want to save that? No, I'm going to get rid of that. So we got people in stats, and we're looking at levels of depression of people in stats, so I want to say, let's take a look at that. So we're going to go under Analyze, Descriptive Statistics, and now instead of, if we do Descriptive Statistics, that just tells us the same things, mean, median, modes, and standard deviation, so I don't use that one very much. But the second one down from that basically says Descriptive Statistics, and then Explore. Doesn't that sound like a good word? Explore. So we click on that, and what we can do is stats or not versus all these things. So we're going to look at how people are doing with time, all these things, and don't worry about it not making sense. It doesn't make sense, I know. Under statistics, we can say we want descriptive statistics. Absolutely, that would be mean, medians, modes, standard deviations, etc. Oh, there's this other button that says outliers. I want to see outliers because those. Now, some of you guys used the word outlier in your assignments to this point. Just because you're outside of 1.96 doesn't mean you're an outlier. So get rid of that language. Outlier has to be defined by something. SPSS has their own definitions of outliers. Okay, so do not use outliers. Just because you're outside of one, that means you're significantly different than everybody else, but you're not an outlier. Okay, it's not the right use of the word. So I say continue, and then it says plots. It's like, oh, I want to see a histogram. That's nice. I want a normal probability plot on that. I don't really. Oh, I'll leave that there. A lot of times you got stem and leaf plots. I don't really like stem and leaf plots, so you don't need to do one. And we don't need to do Levines or anything like that, so we say continue. And then we can say okay. So SPSS goes away and calculates this for us. It's nice. It tells us. In fact, SPSS tells us exactly what it's done. Right at the top, it tells us where the data is, what data, what's the file names, and that sort of stuff. It tells us what it's producing. And then we get sort of the number of cases, so we know how many subjects we got. Then we get the descriptive statistics, time spent revising stats, and then we got statistics and standard error, and we got the confidence interval. Whoa, look at that, there's a confidence interval for us too, that's nice. Mins and maxes, quartiles, skewness, kurtosis, and it does it for each of the different variables, all three variables for each of the different groups. It divides it into groups, so if you wanted to look at males and females, that's the way you can do it. If you want to, and I give you guys a data set where I want you guys to look at different groups. It also tells us the extreme values, the highest five numbers and the lowest five numbers. This is a great way to look for errors. So if you scrolled along and all of a sudden you had a number that was like 82 and everything else was lower than 20, then you'd say, okay, there's probably an error there. So you can look for errors there. We'll talk more about that next week. Then it gives us a histogram, and this is for each of the different variables. Now we'll talk about these QQ plots and PP plots next class, so don't worry too much about them. This is a box and whisker plot. Okay, and you do have to know what a box and whisker plot is. This is the SPSS does this, and it's, of course, we got stats, in stats, and not in stats. These are outliers, and the stars are extreme outliers. Okay? Understand? Excellent. This represents the median score. This represents the interquartile range. This represents the highest and lowest scores in that group without counting them as outliers. So before they get defined as outliers. Okay? You could actually take that and copy it and paste it, but I would be very unhappy with it because it wouldn't be size 18 font. So you can edit this, and Jamie and Jordan are very good at editing. In fact, Jamie and Jordan can show you how to set up a template. So every time you produce a graph, it will all be correct, but you can click on this. Usually if you double click on anything, you can make it happen for yourself. So you can double click on it, you can change the background, for example, because the pale shaded gray is sort of irritating, and get rid of that. Okay? Close. You can change the size of the, double click on that and say, I want it to be size 18. And voila. Okay, so do not be giving me graphs that do not fit with what I expect. So once I get it perfect, you can save it as a template, and everything else after that will be done. So once it's done, I can actually then click on it, and I can say copy, and I can go over to my Word document on a separate page. I'm going to insert a break right there, and I'm going to paste that document there. And I'm going to say figure 2. Italicized, space. This box and whisker plot shows. And then you need to tell me what everything is. What are the whiskers? What are the stars? What are the circles? Okay, if you do not tell me what everything is, I'll be like, what is that? I don't know. All right, so then we go back. SPSS, so those are the two things you have to do under Analyze Descriptive Statistics, okay, for now. You might want to do graphs. You can go under Chart Builder, and you have to do a few graphs for this assignment, so you click on Chart Builder, it says, you're going to blah, 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 now you're in a straight. So it guesses, look at that, it guesses for me right away. Actually, that was the one I did earlier today, so let's do that one. So there's males and females, x-axis, y-axis. You can say error bars. Look at that display error bars. In this case, you can trust SPSS. That's like going to the Greek restaurant from Osaka. You can trust it. Okay, maybe not, but the concept is there. You can trust SPSS. They can tell you. It tells you how actually it's calculated. You can say, I want confidence intervals. I want 95. Apply, and it do that, and then we can actually basically add in here whatever we want. So, and then we got males and females on this side. So we should be able to. In fact, I sort of screwed this up. So let's do this gender not. There we go, and we say OK. And now we've got our graph with. We got our graph with males and females. Somebody say something? Okay. So again, I can edit this to make it so that I like it. And if you guys spend the time to make a graph that I like, well, and it works, then save that as a template. Use it time and time again. There's 100 ways to save yourself a lot of time on this class. And because the exam is timed, you're going to have to make these graphs in less than an hour and a half, an hour and 20 minutes. You're going to have to get proficient at this. Remember, I am not here to judge how good you guys can be in 5 hours. I'm here to judge how good you can be in an hour and a half. So you have to internalize it. Yes?
If we're doing the exam and we're allowed to bring stuff in, should we be making these templates?
Oh, shit, yeah.
Well, on the computer we expect to be using for the exam, or are we allowed to bring in our laptop?
You bring any laptop you like.
Okay.
You do anything but bring a friend, Kevin.
For the exam.
For For the exam, exactly. What's that? Is what? Well, you can't bring them. You just can't talk to them. Scatter plot, last thing I'm showing you guys, okay? Scatter plot, I'm just doing two simple scatter plots, so all you do is pick scatter plot and then drag that up there. And then basically say, I'm going to do time spent revising and exam performance. Put that down there. Exam performance. And then if you want to do by gender or by stats or not, you can actually drag that over there. So now we can actually have two bars. So we're going to say, okay. And now we've got a scatter plot. If you double click on that scatter plot, you get a dialog box. And in that dialog box, you can go under options. And then it says, elements, you can say fit line to total or fit line to subgroups. And if there was males and females, I can fit a line to the males and females separately. That way I can compare them. I can click that. And it says linear, yeah, I want a linear trend line, so I close that, and now I've actually got a graph that has two lines on it, one representing males, one representing females in this case, and I can sort of compare the lines of best fit. They actually give me these here. If you get this, your equations, you should be able to move these out of the way once you, at some point in time, and I can't remember how, but it doesn't matter. Goodbye.
Is there a reason on Excel, like why you didn't just